Let's go ahead and continue our discussion with refraction by talking about the law of refraction. Now, this is commonly known as Snell's law, and it's the mathematical relationship between the index of refraction of the two different mediums or media and the angles between the rays and the perpendicular of those medias. Okay, so the idea that we had been looking at with refraction was that the ray of light or some ray of light would come in, hit a surface, and change direction. But we didn't talk about how that would happen. Okay, so this is a quick, very simplified, um, I guess, figure of how this works. So we have an incident ray of light that comes in and will hit whatever the surface is, right? So this is going to be the surface between, in this case, sidewalk and grass, okay? And as soon as it hits that grass, it changes direction, okay? We've seen this, we have looked at this. But now we want to be able to put this into terms mathematically, okay? So we have the first index of refraction in 1, in this case is the sidewalk, times the sine of theta 1, which the thetas, remember, are to the perpendicular of the surface, right? This is perpendicular to the surface here, okay? So I'll draw it like that, okay? So this is the perpendicular. So this angle here is equal to N2, or the index of refraction of the grass in this case, times sine of theta 2, which again, it is perpendicular to the surface here. That's where we measure that from, this angle here. Okay, so this is the idea, okay? And no matter which direction our light ray goes, the same will hold. So in this case, we have the incident ray coming from the sidewalk into the grass. On this section, part B over here, has the incident ray coming from the grass to the sidewalk, okay? And the same law will hold, this law here. N1 sine theta 1 is equal to N2 sine theta 2, okay? So this will tell us where that light ray will bend to, okay? So let's look at an example. So find the index of refraction for medium 2, assuming medium 1 is air and the incident angle is 30 degrees. The angle of refraction is 22 degrees. So let's go ahead and draw this first, which I know that I can just start plugging in numbers, but if we don't understand how it looks, it's going to be a little bit difficult. So we have our surface here. Up here at the top is air, okay? Then we have some other medium. I'm just going to say it's 2, medium 2, whatever that is, okay? And we have an incident angle. Remember, that is going to be incident, or sorry, the angle makes with the perpendicular. So let's say it's about, I know it's a little bit wonky, but it'll work. So this is 30 degrees. Okay, so this is our theta 1, okay, or incident angle. Okay, then we have the angle of refraction, which is 22 degrees. So it's not as wide here, it's not that much. That might be a little too much there. Let's see, erase that real quick. Let's go like that. Oops. And this is 22 degrees, and that's theta 2. So we know N1, we want to know N2, okay? So remember our equation, N1 sine theta 1 is equal to N2 sine theta 2. So we can rearrange this to be N1 sine theta 1 divided by sine theta 2 is equal to N2, okay? Or N2 is equal to N1, which is air. So let's look that up. What is N1 for air? Let's go back. That is 1.000293. So 1.000293. Well, it's really wonky, but it's there. Okay, so N1 is 1.000293. And then we have sine of theta 1, which is 30 degrees. And divide that by sine of theta 2, which is 22 degrees. Okay, so let's do that in our calculator real quick. We have 1.000293 sine 30, and we divide that by sine 22, and we get that N2 is equal to 1.335 approximately. Okay, so we have the index of refraction of medium 2. Now we could even go a step further and decide which medium this is. So let us do that. So 1.335. 1.335. That's a contender, fresh water. 1.33. Yep, it must be fresh water. So water. Okay, so this is the idea, what we will be seeing on the homework and so forth. Okay, so given one medium, the index of refraction, the angle at which it's coming in, find maybe the other index of refraction or the angle at which it changes direction to. Okay, all right, let's look at one more example. So suppose that in this situation that we just saw, light goes from air to diamond now, where we have an incident angle of 30 degrees. Calculate the angle of refraction, theta 2, in the diamond. So we're going to have something similar. So we have air as N1, N2, okay, and it again goes in 30 degrees. And we want to know what this angle is, theta 2. Okay, so let's see. N1, that was 1.000293. Whoops, wrong direction. Perfect. And then what about for diamond? Let's look at this again. It looks like diamond is 2.419. That is the index of refraction. 2.419. Okay. And we are looking for the angle 2. So we know N1 theta 1 is equal to N2 sine theta 2. And we can rearrange this to be N1 sine theta 1 divided by N2 is equal to sine theta 2. Now what we'll need to do is take the sine inverse of both sides here. So I will need to do, I'm just going to write it here, sine inverse of that and sine inverse of that. Just how we do with tangent thetas. If you guys remember, for solving for what was it? Solving for the angle at which a vector would be traveling. So we'll do the same sort of thing here. So if I take the inverse of sine so the sine inverse of sine, there we go. Those will cancel and we'll get theta 2 is equal to sine inverse of N1 sine theta 1 divided by N2. So then we can plug everything in. Theta 2 is equal to sine inverse. N1 is 1.000293 sine of theta 1, which was 30 degrees. Divide that by N2, which is N of diamond. Okay. Now we can put that into our calculator. So you can do it in a couple different ways. Make sure that you are in degree mode in your calculator because that's what we're looking for. So we can find this first and then take the sine inverse of it, or put all of this into our calculator at once. It's up to you. 293 sine 30 divided by 2.419. And I'm going to just double check my answer. So for now, I'm getting 11.9 degrees, but I'm going to double check. 2.419. Yes, okay. So my theta 2 is 11.9. So it bent quite a bit in this direction. So if I get a different color, where's my, it would be about here. That's about 11 degrees, say, okay? All right, and we already knew that it was diamond, so I don't need to guess what material it is in this case, okay? All right, so let us look at one more concept here before taking a break, is that we can have total reflection of something, okay? So if we have an incident angle, theta 1, that produces an angle of refraction of 90 degrees, then we have an angle that is the critical angle, okay? So let's look at this here. So we have an incident ray coming in, and we have a reflected ray. So if we have, we'll have a reflected ray and a refracted ray, I guess I should say. And if we have some angle that that incident ray hits from, okay, this is called the critical angle, theta c. So if we move our incident ray to where it is at that theta c, we'll not only have that reflected ray, right, and that'll be the same, right, because law of reflection, law of reflection, and then we'll have a theta 2 that is 90 degrees. So it's exactly perpendicular or along the surface, right? It's exactly traveling along the surface there. So this is, let's see, this is where we have theta 1 is less than theta c, okay? This is where theta 1 is equal to theta c, okay? And this here is where we have something called total internal reflection. So this is theta 1 is going to be only having reflection. Okay, so there's no refraction in this case. So we have theta 1 is greater than theta c in this case. Okay, so let's look over here for a second. So we have that critical angle at which we'll have this refraction, right? This refraction along the surface, we can say. Total internal reflection, like I mentioned briefly, is where all the light is reflected back into the medium. So that's achieved when the incident angle, theta 1, is greater than the critical angle, okay? So like I said here, theta 1 is greater than the critical angle, okay? And using Snell's law, we can look at what that critical angle is. So when the incident angle equals the critical angle, or theta 1 is equal to theta c, the angle of refraction is theta 2 is equal to 90. That's what we have here. Okay, so we can set up Snell's law. So we have N1 sine theta c, which is here. Then N2 times sine 90 degrees, which would go to 1. That's why it wasn't there. Then we can, where this is, I'm just going to put equal to 1. So then we can solve for what that critical angle is. And so the critical angle is equal to sine theta 1, sine inverse of N2 divided by N1 as long as N1 is greater than N2, meaning we're going from an index of refraction that's greater to the less than, right? So it would be like going from greater, the water to air. So example, I'm just going to write an example, water to air, where water is 1, air is 2. Okay, hopefully you guys followed that bit right there, but this is the idea that we can, or where we can find the critical angle of a medium, okay? All right, so I'm going to go ahead and pause here, and then we'll continue on in the next lecture.